Okay, here is the question we have. By first factorizing completely, x cubed plus x squared minus 5x plus 3, find this integral. So let's focus on this integral later. For now, let's just factorize this cubic. So let's call f of x is equal to this cubic, x cubed plus x squared minus 5x plus 3. And the way we factorize cubics is we guess a solution, we guess a root of this cubic, and then using that guess we reduce this cubic into a quadratic, and we know how to factorize a quadratic. Okay, so we're going to guess a solution, and the values that we're going to use are going to be 0, plus minus 1, plus minus 2, and plus minus 3. So in most cases you will find a solution in these values, and you can use that to reduce this into a quadratic. So let's use our first value, f of 0. I know it's not going to be equal to 0 because we have a 3 here. We will use f of 1. So f of 1 is equal to 1 cube plus 1 square minus 5 times 1 plus 3, which is equal to 0. So we found a root. Luckily, it was the first value that we tried. If this was not equal to 0, then you would try the next values and keep going until you find a root. So we can say that x is equal to 1 is a root, and that implies that x minus 1 is a factor. So we found one factor of this cubic, and we can now divide this cubic, x cubed plus x squared minus 5x plus 3. We can divide this by the factor that we found, x minus 1, and this should be equal to some quadratic. This should be a quadratic. Alright, and then we can factorize that quadratic using middle term splitting or any method that you like. Okay, so you can use polynomial long division here. What I'm going to use is something called synthetic division. If you don't know synthetic division, you can maybe search on YouTube. You can find plenty of videos. So the way we use synthetic division is we write the coefficients of the polynomial here. So this is my cubic. I have these coefficients 1, 1, negative 5, and 3, which I wrote here. And I'm dividing by the root, which is 1. Okay, so let's carry out this synthetic division. If you already know synthetic division, very nice. If you don't, the way we carry it out is we bring this 1 down here and multiply whatever we have here with our root. So 1 times 1 is 1, we can write it here. Add vertically, 1 plus 1 is 2. We can multiply that by the root, so 2 times 1 is 2. Again, add vertically, we get a negative 3. Negative 3 times 1 is negative 3, and we can add vertically, we get a 0. And this last part here is the remainder. And this should be 0 because x minus 1 was a factor, and dividing by a factor leaves a remainder of 0. And these are the coefficients of the quadratic. So this means our quadratic is x squared plus 2x minus 3. And now we can factorize this quadratic. So factorize x squared plus 2x minus 3. We can split the middle term, so we can write this plus 2x as plus 3x minus 3. We can factor out x from the first two terms, we get x plus 3, and minus 1 from the second two terms, we get x plus 3. So this is equal to x plus 3 times x minus 1. And now we have it completely factorized. The cubic x cubed plus x squared minus 5x plus 3. This can be written as x minus 1, which was the factor that we had guessed before, and then the two factors that come from the quadratic, so x plus 3 and x minus 1. And these x minus 1s can be combined, so x plus 3 times x minus 1 squared. So the first part of the question is done. We have factorized completely this cubic. Now let's focus on this integral. And if you notice, this cubic here that we just factorized, it's in the denominator of this integral. So instead of this cubic, we can just replace this with the factorized form. Let's see how it goes. We have the integral of 2x squared, what was it, plus x plus 1 divided by the cubic. and instead of the cubic I will write the factorized form x plus 3 times x minus 1 whole square dx. So we have to evaluate this integral, and upon looking at it, whenever we have a form like this, we have some linear factors in the denominator, you should have some bells going on in your mind. This is kind of a hint to use partial fractions. So we want to split this fraction into multiple fractions by using partial fractions. So this whole fraction, 2x squared plus x plus 1 divided by x plus 3 times x minus 1 whole squared, this can be written as a over x plus 3 is a linear factor, plus b over x minus 1 is also a linear factor, but x minus 1 is a linear factor of multiplicity 2 because we have a power here of 2. So we write another term c over x minus 1 whole square. If you had a power of 3, then you would also write another term d over x minus 1 to the power of 3. If you had a power of n, you would keep going until you reach the power of n. That's how you do partial fractions when you have a denominator in this form. Now we can multiply both sides by this denominator. So it's 2x squared plus x plus 1. That's identical to a times, when we multiply this denominator on the right side, x plus 3 will cancel out in the first term, we get x minus 1 whole square, plus b times, for the second term, one of these x minus 1s will cancel out, so x plus 3 times x minus 1 plus c times, and when we multiply it by this third term, x minus 1 whole squared will cancel out, we get x plus 3. Okay, this is not an equality, this is an identity, and the difference between an equality and an identity is that an equality is valid on limited number of values of x, but this identity is valid for any value of x. So this allows us to choose any value of x that we want, and we're going to choose these values very smartly. So we're going to choose x is equal to, let's see, so if I choose x is equal to positive 1, then this term will cancel out, this term will also cancel out, and only this term will remain. So by choosing the value of x smartly, x is equal to 1, we can simplify our calculation. So we have 2 times 1 squared plus 1 is equal to, this term should cancel out, this term should cancel out. Because of these terms here, only the term in c will be remaining, so c times 1 plus 3. So we have 4 is equal to 4c, which implies c is equal to 1. So we found the value of c. We can choose another smart value, so choose x is equal to negative 3. The reason we're choosing negative 3 is if we plug in negative 3 here and here, then these terms will vanish and only this term will remain. So once again it will simplify our calculation. So we have 2 times negative 3 squared, negative 3 plus 1 is equal to a times negative 3 negative 1 square. So this is 16 equals 16a, so a is equal to also 1. So we're out of these smart values now. Now we're free to choose any value, and I'm going to choose 0 because of this 0, a lot of these terms will also cancel out. So here we don't have to write any of these. So this will be 1 is equal to a times negative 1 square plus b times 3 times negative 1 plus c times 3. And now I can also plug in the values of c and a. So here was the value of c, here was the value of a. I can plug them here. So 1 is equal to a minus 3b plus 3c, and the values of a and c are 1, so this is 1 minus 3b plus 3. These will cancel out and we get 3b equals 3, which implies b equals 1. So we got all values a, b and c, and they're all equal to 1. This does not happen in every case. I'll just copy all of this to the next page. And now this partial fraction can be written as 1 over x plus 3 plus 1 over x minus 1 plus 1 over x minus 1 whole squared. And instead of taking an integral of this, we can now take an integral of this, and these three terms are easy to integrate, easier than this whole integral. Right, so our integral becomes integral of 1 over x plus 3 plus 1 over x minus 1 plus, and this last term I can write as x minus 1 to the power of negative 2 dx. And the reason I did this is because for this term to integrate I have to apply the power rule. For these two terms I don't have to apply the power rule. For these I can use log. So the integral will be, for the first term it is ln of x plus 3. For the second term it is ln of x minus 1. For these two I have used this formula that the integral of f prime of x over f of x is equal to ln of f of x. So if you have the derivative of the denominator available in the numerator, then you can write the integral as log of the denominator. So here we had x plus 3 and its derivative is 1, which is available in the numerator, so we can write this as ln of x plus 3. Similarly, for x minus 1, the derivative of x minus 1 is 1, which is available in the numerator, and this again we can write this as ln of x minus 1. For the last one we can use power rule, plus this is x minus 1, we increase the power by 1, so this will become a negative 1. We divide negative 1 and then we multiply the denominator by the derivative of whatever is inside. So the derivative of x minus 1 is just 1, and that is what I have written here. And this is our final result. We can just do some simplification. We can combine the logs. So this is ln of x plus 3 times x minus 1, and the next term we can write as minus 1 over x minus 1. In the end, add a constant of integration, and this is our final solution. So I hope you enjoyed this walkthrough. This was a very long question, very hard one. I think it brings together a lot of different concepts from a lot of different areas. This was for 12 marks, as you can see here. It contains the factor theorem, some polynomial long division, some partial fractions, integration, so kind of a mixture of a lot of topics. Anyway, so that's it for this video, and I will see you next time.